Now you can see the simple question based on the symmetrical component. This is very simple questions. So we are starting from the basic. Now you can see it is asked in the year 2011. The line current of a three-phase power supply R. This is IR, this is IY, and this is IB. Now you can see this figure, and we can say this is unbalanced current. And this is unbalanced current because magnitude is not equal and the phase angle are not equal. So we can say this is our unbalanced current, and the question is asked about the zero sequence current. So we have seen the zero sequence current. It means you have this value. We have seen the formula of ABC is equal to A, and we want to find I120. So this is the basic formula. So we have seen two methods. If you want to find the IABC through I120, we will use the matrix A. But if you want to find the value of I120 from IABC, but here the sequence is not ABC, it is RYB. So we can say like this, IABC is nothing, it is IRYB. So what we want? We want 120 from RYB. So we have seen the matrix we are using, this is your A inverse. चलो अब हम लोग को लिखना है, मान लो I120, so we know IR1, IR2 and IR0. Similarly like IA1, IA2 and IA0 because the reference is phase A. So here the reference will be phase R because it is starting from the R. This is the simple nomenclature. So we have seen we will use 1 by 3, first row, first column, second row, second column, third row. So as we know, the matrix of A is given by 1 1 1, alpha square alpha 1, alpha alpha square 1, and we have seen the property first row, first column, second row, third column, and third row, second column. So this is the value of A inverse. We want to find the value of 120 through ABC or RYB. So this is your RY, this is your RY, this is the IB. What we want? We want only zero sequence. So how to write zero sequence? We can say the zero sequence will be equal to 1 by 3 IR plus IY plus IB. It means we have to add all this current and we will take 1 by 3. So it's okay. 1 by 3, take all the real parts. 3 plus 2, this will be cancelled, it will be 3 plus imaginary part 5 plus 2 7 minus 1 6. So we are getting J6. So the answer will be 1 plus 2J. So this was the option given in the question and this is the answer. This is the basic rule. But here the question was zero sequence. The question may be find out the positive sequence, find out the negative sequence. So this is the way you can calculate any value. So this was about the question number 1 about the current. The sequence may be ABC, the sequence may be RYB, but there should be not any confusion. The steps you should know. What we are going to find, if we are going to find ABC from 120, we will use the matrix A. If we want to find 120 from ABC or RYB, doesn't matter, we will use the A inverse. So we know the matrix A is given by 1 1 1, alpha square alpha 1, alpha alpha square 1, and the rule you know, first row, first column, second row, third column, third row, second column, and the magnitude will be 1 by 3. So this is the rule to find the value of current. Now we saw the question based on current. Now we will see the question based on the voltage. Here it is given VAN1, VAN2, VAN0 is given, and we are going to find the value of VAN, VBN, VCN. Now the trick is we have given 120, we will find A, B, C. So which matrix we are going to use? We will use the matrix A. So in this way we can judge where to use A and where to use A inverse. It's okay, it's quite simple. So what should be the value of VA, VB, VC? We have seen the matrix and the value of A matrix is given by 1 1 1. This is alpha square alpha 1, alpha alpha square 1, and this is VAN1, VAN2 and VAN0. This is also the voltage with respect to neutral. So we can say this is VAN, with VBN and VCN. It's okay. Now what should be the value of VAN? VAN will be equal to simple the addition of VAN1 plus VAN2 plus VAN 0. So the value we will get 50 at an angle 0, 20 at an angle 90 plus 10 at an angle 180. Now in the examination you don't have any KLC whether it is ES or gate. So we have to use the common sense. We know real part, so only 50 cos 0 plus J 50 sin 0. बट अभी हम लोग लिख रहे हैं, बट एग्जाम में आप लोग सब समझ में आना चाहिए कब कहाँ लेना है कहीं नहीं लेना है. प्लस 20 cos 90 plus J 20 sin 90. It's okay. It will be equal to 10 cos 180 plus J 10 sin 180. So the values we are getting like this. 50 cos 0 we will get 50. It means whenever there is angle 0 there will be no imaginary part because sin 0 0. Here we will get 20 cos 90 will be equal to 0. Here only we will get the imaginary part, so we are getting J20. Here what will happen? Cos 180 is equal to minus 1, sin 180 is equal to 0, so we will get minus 10. So overall we can say if we want to find VAN, so VAN की value हम लोग को मिल रही है 50 plus J20 minus J10. It means 40 plus J20. So the magnitude will be equal to 40 square plus 20 square and the angle will be 10 inverse 20 by 40. But in the examination only magnitude is asked, so we can say the magnitude will be this and the angle will be this. We can find this value by using the virtual calculator. If in question angle is asked, if nothing is mentioned, we can find this value simply and we can take the answer of VAN. Similarly we can proceed for VBN. So what should be the value of VBN? The value of VBN will be equal to alpha square VA1 plus alpha times of VAN2 plus VAN0. So if we take 1 at an angle 240, it is equal to 50 at an angle 0 plus 1 at an angle 120 VAN2 the value is 20 at an angle 90 plus VAN0, so 10 at an angle 180. So if we take, we have seen how to find 50 into 1, 50, angle will be equal to 240 plus 20 into 1, it's okay, it will be equal to 210. This is equal to 10 at an angle 180. Again use the basic concept, 50 cos 240 plus J sin 240 plus 20 cos 210 plus J sin 210. This is equal to only cos 180 plus J sin 180. When you put all the values of cos 240, sin 240, cos 210, all are standard. When you put all the values, we are getting the function like this. When you put all the real part here and imaginary part here, the function is like this. Okay. When you put all the values, we are getting minus 25, minus 10 root 3, minus 10. This will be equal to plus J. It will be equal to minus 25 root 3. This will be equal to minus 10. So when we solve this, so after putting all the values, we are getting this is the real part and this is the imaginary part. When you want, if you want to solve, you can take real part whole square plus imaginary part whole square. We are getting the answer is 74.6 something, 74.64 volt. Suppose you are in the need of the angle. So what we can do, we can see this is the negative of the real part, this is the negative of the imaginary part. From the quadratic system, we can say our operating point is lying in the third quadrant. So angle should be, if you want to write in terms of positive, so the angle should be 180 plus or it should be less than 270 if we are writing in terms of positive. But if you want to write in terms of negative, so definitely the angle should be less than 180. If I take 10 inverse this by this, so I am getting 45.53. So definitely the angle will be 180 plus 45.53. So it should be equal to 225.53. It's okay. If we want to write in terms of negative, so the second option will be 180 minus 180 plus 45.53. So the angle will be equal to around 134.47 degrees. So this is the answer if you want to find in terms of exact, but in the question only magnitude is required, so magnitude you can manage. Similarly for phase C, the formula will be this, because we have seen how to write VAN, VBN, VCN in terms of 1 to 0. So when you put all the values is this. Similarly, we can proceed like this: 50 at an angle 120. This will be equal to 20 at an angle 240 plus 90 will be equal to 330, and this is equal to 10 180. When we resolve all these components, we are getting, so if we put all the values, we are getting the real part is negative, imaginary part is positive. If you want to find the magnitude, only you have to take the square of real part, the square of imaginary part. After solving, we are getting 37.6986. This is the answer. But suppose if you are in the need of angle, then you can see this is minus of real, this is plus of imaginary. So according to the quadratic system, this is plus of real, this is minus of real, this is imaginary, minus of imaginary. So according to the quadratic system, we are getting the operating point in the second quadrant. So what we can do, we can take tan inverse real, sorry, imaginary upon real. We are getting 62 point something. We are getting 62.048, but we know the operating point is lie in this region, so the angle should be greater than 90 or less than 180. So we can take the answer will be 117.951. So this is the process. You can calculate the value of unbalanced voltage by using phasor, and we are not using here scientific calculator. We are focusing only the gate point of view, how to approach in the gate. In the gate, if the question is asked, it will ask only one point, either VBN, either VCN, VBN or VCN. It will not ask all three questions. So we have seen how to approach in this question without scientific calculator. Now this is somehow little bit tricky question. It is given phase A current IB2 and IC0, and this is asked in the GATE 2014. So we can say that scientific calculator was allowed, and without scientific calculator how we will approach, we can see here. This is the asked question. If you are going, you are going to find the value of IB. So according to the basic, the value of IB will be equal to IB1 plus IB2 plus IB0. These three values we should know. Now we can see one by one. IC0 is given, and we know the property. IA0 equal to IB0 equal to IC0. So we can say this is equal to 3 at an angle 90. IB2 is given, so there is no issue. This is 4 at an angle minus 150. IB1 की वैल्यू नहीं पता, इट्स ओके, वी कैन से IB1. सो हम लोग को IB1 फाइंड आउट करना है. सो IB1 कहाँ से निकलेगा? द रिफरेंस इज IA1, IA2 and IA0, and the value of IA is given. So we can say, see here, we have to use the value of IA. The value of IA is equal to IA1 plus IA2 plus IA0. So we can say it's okay. It is given 1 at an angle minus 90. We don't know the value of IA1, but we can find the value of IA2 through IB2. This is negative sequence, and we know negative sequence follow opposite to the supply sequence. So if ABC is given, so it will be A, it will be B, it will be C. This is 2, 2, 2. So we can say VB2 is equal to alpha times of VA2, and what we want here, we want to write IA2, so we can say similarly IB2 will be equal to alpha times of IA2. So the value of IA2 will be equal to IB2 by alpha. It's okay, quite simple. The value of IB2 is equal to 4 at an angle minus 150. Here it will be equal to 1 at an angle 120 plus IA0. The value of IA0 will be equal to 3 at an angle 90. It's okay. We can find this value. What we can do here, see here, this is 1 at an angle minus 90. So we can say cos 90 plus j sin minus 90. Here we also get minus, but because of cos of minus is equal to cos of theta, there is no need to write like this. It's okay. We are going to find this value IA1. It will be equal to 4 at an angle. If we shift here, so minus 150 minus 120, it will be equal to minus 270. So the angle is 4 at an angle minus 270. So what will happen? It will be equal to cos of minus 270 plus j sin 270 minus, and last it is equal to 3 at an angle cos of 90 plus j sin of 90. When we put all the values of cos 90 in the log, we will get all these values 0, 1, minus 1. We can put all this value. We are getting the function is like this. So we can say the value of IA1 we are getting minus of 8g, but we are not interested in minus of, we are not interested in the IA1. We are interested in the, we are interested in IA1. From this we can put here by relation of alpha operator. Okay, we have find the value of IA1. Now we are in the need of IB1. So what is the relation? So positive sequence is like this, A. So we can say IA1, this will be equal to IB1, this will be equal to IC1. So we can say the value of IB1 is equal to alpha square times of IA1. So what we will get? We will get, okay, when we put IB1 is equal to alpha square times of this, so we are getting this value in PU. So when we put this value in terms of the IB, so we are getting IB1, we know this value, we know this value. What we have to do, only we have to use the basics. So we are getting 8, 150, 4, minus 150, 3, 90 degree. So we are going to break this cos plus sine, cos plus sine, cos plus sine. We are getting real part is this, imaginary part is this. So when we take 6 root 3 whole square plus 5 whole square, the magnitude we will be get 11.532. The angle, you can see the real part is negative, imaginary part is positive. So definitely angle will be remain in the second quadrant. So angle will be greater than 90 degree or less than 180 degree. So if we try to find the value of angle, so we can say the angle will be equal to tan inverse, imaginary is 5, real is 6 root 3. So it's okay. When we put this value tan inverse imaginary upon real, we are getting 25.693, but it is not possible. So we can say the answer will be 180 minus of theta. So we are getting 154.3066. So this is the procedure how to find any values without using scientific calculator. You can use virtual calculator, you can solve any question. And the next question it is given, in a 3-phase 4-wire system, during abnormal condition, the values of IA, IB and IC is given, and it is asked find out the positive sequence, negative sequence and zero sequence in the line A, and this is current in the neutral circuit or return circuit. Now it is quite mentioned this is 3-phase 4-wire, so we can understand the question is about the star configuration. So what will happen in star configuration? Suppose this is your star configuration. This is your phase or line current, both are same. So this is your IA, this is your IB and this is our IC. The phase sequence is ABC, sorry ABC. Now it is given 3-phase 4-wire, so it's quite obvious there will be neutral. It's quite obvious when you apply the KCL here, we will get the value of IN is equal to IA1, sorry not IA1, this is equal to IA plus IB plus IC. It means in the question it is asked find out during abnormal condition, we know very well this during abnormal condition this line current A will break into 3 parts, IA1, IA2 and IA0. It means we are going to find this value. The question may be any value. Find out the positive negative sequence, zero sequence of line B, line C, whatever. And the second question is this, you are going to find the current in the neutral wire. It's okay. We'll start from the basic. Again you can see which values are given, with the values are A, B, C are mentioned. It is asked about 1 to 0. So what is the trick? If we want to find 1 to 0 from A, B, C, so which matrix we are using? A inverse. So we can say I1 to 0 is equal to A inverse I A B C. So we know very well IA1, IA2 and IA0. The value of A inverse is equal to 1 by 3. So what is the value of A? So अगर आपको A inverse निकालना है तो आपको A पता होना चाहिए. So the value of A is given like this. So the A inverse will be first row first column, second row third column, third row second column. So we can say the value of IA1 equal to 1 by 3 IA plus alpha IB plus alpha square IC. Similarly, IA2 equal to 1 by 3 IA plus alpha square IB plus alpha times of IC. Similarly, IA0. The value of IA0 is equal to 1 by 3 IA plus IB plus IC. When you put all the values, so we can say it will be equal to 1 by 3. The value of IA is given as 100 at an angle 30. It is 1 at an angle 120 into 50 at an angle 300 plus 1 at an angle 240. The value of IC is given as 30 at an angle 180. So what will happen if we put all the values, if we break in cos sine, cos sine, cos sine. Similarly here, if I put here 1 by 3 100 at an angle 30 plus 1 at an angle 240 into 50 at an angle 300 plus 1 at an angle 120 into 30 at an angle 180, and simply it will be equal to 1 by 3 times of IA plus I plus IC. So it will be equal to 100 at an angle 30 plus 500 at an angle 300 plus 30 at an angle 180. So when we use the basics, we are getting the values this and this by using the virtual calculator. When I put all the values, I am getting the positive sequence, negative sequence and zero sequence. This is the value. This is quite difficult by using the virtual calculus, so we can use the scientific calculator because it is not the question of gate. This is the question of book. So this is only for practicing. Now this is the important point. Current in the neutral circuit. So from diagram we can say the neutral current will be equal to IA plus IB plus IC. So you have to take the vector addition. This is the first method or basic method. 57.98, 43.29 plus 18.972, 24.967 plus 27.29 at an angle 4.69. So it will be quite difficult if the question is asked in the competitive exam. So we can say if you want to find a neutral current, so we can see the trick. The neutral current is equal to IA plus IB plus IC. Now IA can be written as IA1 plus IA2 plus IA0, because in abnormal condition the phase current or line current will be broken as this. IB will be equal to IB1 plus IB2 plus IB0. The phase current C can be written as IC1 plus IC2 plus IC0. Now you can see simply it is the addition of IA1 plus IB1 plus IC1. It is the addition of IA2 plus IB2 plus IC2, and we have seen this is the balanced vector. So what will happen if we add IA1 plus IB1 plus IC1 will be equal to 0, because they have the magnitude of, you can see here, this is the balanced set of vector. So we can say this is IA1, this is IB1, this is IC1. So when we add these vectors, we will get the 0 value. Similarly, IA2, IB2 plus IC2, it will be also 0 because it is also balanced. Only the direction of rotation is different from the positive sequence. If it is follows ABC, it will follow ACB, but when we add this, we will get 0. So finally, we are getting this time will be equal to 3 times of IA0, IB0 or IC0, whatever. So it's simple. If we have calculated the value of zero sequence current in the line, so from this zero sequence directly we can calculate the value of neutral current. So neutral current will be equal to 3 times of IA0. So the value is 3 into 27.29 at an angle 4.69. So the answer is 81.87, 4.69. And if you solve by using this function, it will be quite difficult. If you have scientific calculator, then you can solve. By virtual, it is quite difficult. So for competitive exam, you have to focus on this method number 2. Whenever there is a neutral current, use this basic property, and neutral current is always equal to 3 times of IA0, always. This is equal to 3 times of IA0 during abnormal condition. So this is the final answer of the neutral current.